So spiral matrix, all they want us to do is go through the matrix in a spiral while adding those elements into an array or a list and then return the list. So I've seen some people, the way they do this problem is where they set, let's say they have these boundaries, and you could just think of this as like row 0 and whatever this last row is. I guess this would be row 2, and this would be column, whatever columns this is I guess column 6 or 5, something like that. But anyway, the numbers aren't important. They think of these red boxes as boundaries, and all they would do is they'd print out the first row, or the entire row, so all the way to the end, and then they would move their boundary down. They would cut it off here, and then they'd print out the next row, or not print out, they would add to the list, going downwards anyway, and then they would update their boundary after they do that. So you would end up cutting all this off. So now your new boundary is like this rectangle, right? And they would do the bottom side, and then they cut this off by updating their boundary after they do that, and then they'd finally do this. They do the left side, cut that off by updating their boundary again, and then finally they'd finish by doing the last. They just repeat it. Let me draw a better arrow than that. And so yeah, they would just keep updating they would just keep looping while updating their boundary after every time that they go across, down, across again, and then up again. So anyway, that's one way to do this problem, but I'm going to do it a different way. And this was actually the way that I came up with without seeing like a solution or anything. So another way of thinking about this problem is that, let's say the most outer thing is a layer, and then the next most outer thing is also a layer. So here we would have 2 layers. These red lines are just using the red lines to show that these are layers. And if we had a bigger and bigger matrix, the way I'm thinking about it is that the most outer thing is a layer, and then so let's call that layer 0. And as we work our way inward, that'd be layer 1, then layer 2, layer 3, etc. And so let's just take this most outer layer. All I'm going to do is print everything across in the first layer. Then because I know I'm going to do the same thing on the bottom, I'm going to stop here when I'm going, when I'm printing downward. And then I'll do the same thing across. And then, the same thing on this side. And then we'll increment our layer. So this would be our next layer. And we'll just repeat it. And then we're done. So this is how I came up with doing this problem, and I'm going to code it out. Oh, there are some corners. So I guess got to go over so a couple things. So first off, like, we have to be able to calculate how many layers do we actually have in a matrix. So based on this. So if we look at this had 2 layers, right? 2 layers. All you'd have to do is look at the minimum of the number of rows and the number of columns. So here there's 6 columns and there are 3 rows, right? Well, this is 1, 2, 3 rows. Okay. So you would look at if we have 3 rows, all we have to do is divide it by 2. And that gives us, well, if this is integer division, this would give us 1. So what we're going to say is if we have an odd number of rows, we just add 1. And this will give us the 2 that we want. This is saying that this is 2 layers. And just to make that super clear, like, let's just say this, we agree that this is 2 layers, right? Because of this. So this is layer 1. This would be layer 2. And if I added, let's say I just added a 4th row here, well, then we would have 4 over 2, which is just 2. And let's just show that there's 2 layers still. So this would be 1 layer, and this would be 2 layers. I can't draw. 2 layers. Cool. So so all we have to do is check if we have an odd number. We take the minimum of the rows and columns divided by 2, and if it's an odd number of rows or whatever, or odd number of columns, depending on which one we took as a minimum, then just add 1 to it, and that's the number of layers. And then from there, we just got to do the whole logic of printing out across, down, and all that. Okay, so let's actually code it out. So first, let's just start by declaring the thing that we're going to return. So this is just a list, and this is the thing we're going to add to. New array list. Do return the list. We need the number of layers. So int layers equals. Okay, so to calculate the number of layers, we need to know whether we have smaller columns or smaller rows, or the min of the two. So let's just call that min dimension equals math.min of the number of rows and the number of columns. And I don't need to worry about an off by one index out of bounds thing here because we're guaranteed at least one row and column. Okay, so we have the min dimension. Let's call it min dimension. And to calculate the number of layers, we need to check first if the min dimension is odd or even. So if it's even, then it's just min dimension divided by 2. For example, if we have 2 rows, then 2 divided by 2 would just be 1 layer. And if it's odd, then if, for example, if we had 3 rows, well, that's actually 2 layers. And so what we want to do is min dimension divided by 2. So 3 divided by 2 would give us 1, but we have 2 layers, so we just need to add 1. Okay, so now we just loop through our layers. So int L equals 0, L for layer, L is less than layers plus plus L. And we're going to add horizontally across, or add horizontally right. And we're going to pass in our matrix, pass in the layer, pass in the list. Okay, and we're going to add vertically down. And I'm going to write these methods in a second. This is just to make the code look nice. So add horizontally the left, pass in matrix, L, and the list, and then add vertically up. Oh my god, I can't type. Matrix, L, list. Okay. We need to start writing those. So private void add, let's just copy paste. I don't want to type that all out. Okay. Then int, pass in the matrix, pass in the layer, pass in the list. Oh my. Been a long day. Okay. Add horizontally right, matrix, layer, list. And now we need to figure out what's our row, what's our column that we're going to, so this is where our starting point. And then we're going to loop through it, and we're going to do something like list.add matrix row column, and that would be it. This would be the entire method. And this is pretty much what all the methods are going to look like. We just need to figure out what the starting point is. So this would just be layer, because we're starting in the top left corner, and layer is going to be 0 in the beginning, then it's going to be 1, etc. Column will also be layer, that's top left corner. And again, layer will be 0, so column will be 0, and this is what we want, 0, 0, and then it'll be 1, 1, then 2, 2. Okay, then we want to say, we're going across, we want to loop through our columns. So we want to say C is less than matrix dot length, so this is the number of columns, minus our layer, so that to make sure that we stop short, on the next iteration of this. And we just want to do plus plus C. So that's done. And since we're already doing horizontal, let's just do the horizontally to the left. Okay, so let's calculate our starting point first of all. So we start in the top. So for horizontally to the left, we have to start from the bottom right corner. So this will be matrix dot length. So this is the last row minus 1. So matrix dot length minus 1 because it puts me in the last row. And then I just want to subtract the layer to make sure I keep going like inwards. And this is the exact same thing, except instead of the row, we're going to do the column. Okay. And let's just delete all this. Okay. So if we want to go horizontally across, we need to decrement through our columns. So we need to do C greater or equal to layer. Yeah, so layer will be 0 the first time. So we want to go all the way to the end. And the next time it'll be layer will equal 1, so we stop 1 short of the end. Okay, and we just want to do minus minus c. And, oh, and then, so I think I mentioned it earlier, but there is one little corner case where if, let's say we have an odd number of rows, so if we have something like, let's just say we had like this is the matrix they gave us, 1, 2, 3. This was the matrix. Well, so we had just have like a 1 by 3 here, or 1 by 3 matrix. So our add horizontally right will add this to our array. So or our list. Let's say this is my list. The add horizontally right will add those 3 elements. But then if we just leave this the way it is, add horizontally left will also add these 3 elements, from starting from the right to the left. So this only happens when there's an odd number of rows. So what we want to do is just check. We just don't want these to compete. And by the way, the reason this happens for an odd number of rows is because we calculated the number of layers, and the layers is basically the min dimension divided by 2. But on if there's an odd number of rows or an odd number of columns, then our add horizontally right and add horizontally left, they're both gonna compete or not compete, but they're both gonna add that center row. So anyway, all we gotta do is check if matrix, do we have an odd number of rows? Matrix.length mod 2 equals 1, so we have an odd number of rows. And so if we have an odd number of rows, and this needs to be down here. And the row equals the middle row. Just return. Yeah, so if we have an odd number of rows and we're at the middle row, just don't do anything, because this guy is going to handle that, and we don't want this guy to do it. Okay, so now let's just do add vertically down. Let's just copy paste this. Just rename this, add vertically down. Okay, and let's just get rid of this, get rid of this, get rid of all that. Okay. And you know what? I might as well copy and paste it for the add vertically bottom, or not down, I'm bottom up, add vertically up. Okay. So let's do add vertically down. So for adding vertically down, we're in the top right row. But remember, where's the whiteboard? So really quick, remember when we're doing downwards, we don't want to include this guy or this guy. We only want to do basically everything in between the whatever our horizontally across and our horizontal methods did. We don't want to include that. Sorry, I'm having a hard time like phrasing it correctly, but I think you guys know what I mean. So anyway, R equals not the first row, but the first row plus 1. And the column, so we're in the top right, so then this would be the last column minus 1, which that would put us in the last column. Actually, I think that's what we want. And then minus a layer. Yeah. So this puts us in the last column, and we just subtract the layer. And yeah, I think we're good. So now let's just do, so for looping downward, that means we're iterating through the rows. So then R is less than the matrix dot length minus 1 minus the layer, and then plus plus R. So this is the last row, but again, this is R less than. So we're doing R less than the last row. So this is actually going to put us at on the first iteration when layer is 0. This will stop short at the second to last row. Okay. And we are almost done. We just got to do add vertically up. So adding vertically up, we're in the bottom left corner. So that means we're in the last row. So matrix dot length minus 2, because minus 1 would put us at the last row. We want to be at the second to last row so that we don't include that, whatever our horizontal method included, minus the layer. Okay, and for the column, we are in the bottom left, so then that would just be layer. Because on the first iteration, this will be 0, and then, yeah, on the next iteration, it'll be 1. Okay, so, and then we want to iterate through our rows in order to go up. So let's do, it would be R is greater or equal to layer plus 1. Because, again, if this is layer 0, we don't want to include that first row. So we just add 1 to the layer. And then we're just going to do minus minus R so that because we're decrementing up in the up direction. And the last thing is, again, if we have an odd number of columns, we don't want this guy to add whatever this guy added, because they're going to both compete for that, like that center column. So we just need to check is matrix, actually, let me fix the spacing. Do we have an odd number of columns? And if we have an odd number of columns and our column equals the middle column, then just return. And I think we're, let me fix that space is bugging me. So I think we're good. Is there anything else? Nope. Let's just run this. Cool. And that's how I thought about this problem. So I know it's a little different from like how other people did it, but I just thought it was a cool, I like thinking about the matrix and layers. Because you can apply that to other problems. So that's why I wanted to do a video on it. But anyway, if you found this video helpful, you can give it a thumbs up. If not, sorry. But anyway, thanks and peace.